everybody, welcome to Lab 4. So part 1 is going to be on the Reynolds number, and part 2 is going to look at the energy grade line and hydraulic grade line. So for our part 1, an important equation is the equation for Reynolds number. So you're going to take the average velocity times the diameter of the piping, and then you are going to divide that by the kinematic viscosity. And then here we have the Darcy-Weisbach equation. And you basically have head loss here equals the friction force times the length of piping or whatever you are specifically looking at divided by the diameter of that piping times the average velocity squared divided by 2 times the acceleration due to gravity. And then over here for part 2 we have the Bernoulli equation. So again, you're going to take the average velocity at a certain point, square it, divided by 2 times the acceleration due to gravity, and then you're going to add that to the pressure at that point, divided by gamma, which is the specific
weight of water,
plus Z1, which is the elevation. And basically you go through and do the same thing, but with your second point. And then this can be deduced down to find your delta H. You can do the same thing using the average velocity at point 2, and the pressure at point 2, including this negative sign here. And for calculating the HGL, you can do the pressure divided by the specific weight of water plus the elevation at that point. EGL, you can do pressure at that point divided by the specific weight of water plus the elevation plus the average velocity squared divided by 2 times the acceleration due to gravity. Good stuff here. And then we've got the EGL minus the HGL, which is equal to V2 squared, so V2 is that second point, divided by 2 times the acceleration due to gravity.
Da da da. All right, good luck, guys. Woohoo!
Hey everybody, welcome to part 1 of Lab 4. So here we're going to be observing the transition from laminar to turbulent flow, and we're going to be using our tilting flume, although it's being kept at a level position, and we're going to keep the water at a constant around 10.5 inches. And then what we're going to do is we're going to inject a little bit of this bright pink coloring into the tube, and we're going to be adjusting the end here, the spigot, so we can see at different flow rates what the transition looks like from laminar to turbulent when we inject the dye. And then we are going to get the discharge rate in mils per second. So we're going to measure at the end of each trial. There will be about 13 trials total. We're going to put this beaker underneath the spigot and measure how long it takes to fill up to whichever measurement we are going to call.
So our water temperature is 19 degrees Celsius.
Hard to see on the video, but we'll take Sam's word for it.
So now we want to take a measurement of the length of the piping. So we're going to use this, line it up with the front of the piping, and do your best to indicate where to start. Oh, my bad. Okay, right around here-ish. I think that's around it.
Yep, so it's the 36 inches plus 24.75 inches is the total length of the pipe.
Now we are going to measure the distance between the 2 piezometers. So 36 plus whatever this distance is.
Plus 10.25, so 46.25 inches is the difference between them.
So now we are going to measure the distance to the inlet of the pipe at the outfall, and then also where the inflow is coming in. So for the outfall, we have 4.5 inches. And now we're going to look and see what the height is over at the inlet, which is, looks like 4.5 again. So we are starting with the spigot opened 1 full turn for our first trial. For the next 12 trials, we're going to open it a quarter of a turn each time, and then we'll be able to see with different flow rates what happens when we're looking at laminar flow going into turbulent flow. So we're going to keep it one full turn open, and we are going to measure the height here on the piezometers. So for the piezometer 1, I think it is. Oh, here, yeah.
Yep.
It is about 3.7 inches. Then for the piezometer number 2, we have, let's see, 3.6. 3.6 inches. Trial 1 flow rate.
Start. 6.24 seconds for trial 1.
Watch it.
To fill 100 mils.
To fill 100 mils.
So this is trial 1, injecting a small amount of the dye. So for trial 2, we're going to open the spigot 1 quarter turn. So now we're going to measure the height in each piezometer.
For trial 2.
For trial 2. So we've got 3.75 inches for the first one. For the second piezometer, we have about 3.5 inches.
Yeah. Yep.
Around there. So this is trial 2, and we're switching to a graduated cylinder just to better catch the flow. The beaker wasn't really doing the job, so we're going to measure this over about 10 seconds, and then we're going to see how high the water level goes. So start.
Stop.
So we have about 340 milliliters
So 340 milliliters in 10 seconds.
in 10 seconds.
Alright, trial 2, releasing the dye.
So this looks like mostly laminar flow. Yes. So now we're going to turn this another quarter turn for trial 3. Turning the spigot open a quarter turn. So now for trial 3, we're measuring the height of the piezometers. So for the first one, 4 inches. And for the second piezometer, 3.75 inches. So now we're going to measure the flow rate, again measuring how much water fills up in 10 seconds.
For trial 3.
Oh, I didn't tell you when to go. Okay, good. We're good.
Stop.
So we have about 490 milliliters.
490 milliliters in 10 seconds. Alright, releasing the dye for trial 3.
This still looks like laminar flow, but it is kind of on the cusp of transitional. So we are on trial 4, and we're going to turn the spigot a quarter of a turn open. To measure the height of the water in the first piezometer, which is about 3.75 inches. And then the second piezometer is 3.3 inches. 3.3 inches. So now for the flow for trial 4. Want me to tell you when, Sam?
Good.
liters in 10 seconds. All right, releasing the dye for trial 4. So the dye is harder to see in this one. I think it's transitional.
We are on trial 5 now, and we're going to open the spigot another quarter turn.
Oh, faster flow.
So we're going to measure the height of the water in the piezometers. The first one is 3.6 inches, and the second one is, if I can get this still, is about 3.25 inches. So now on to trial 5 to find the flow rate. And we're going to use 5 seconds instead, since the flow is much higher. Go.
Stop.
So we have 420 milliliters.
420 milliliters in 5 seconds. Releasing the dye for trial 5.
So trial 6, opening up the spigot, another half a turn.
Quarter turn.
I mean.
Look at that flow.
To measure for trial 6, the height in the first piezometer is 3.5 inches. And the height in the second piezometer is about 3.2 inches.
Right.
Trial 6, measuring the flow. And go.
Stop.
So that was 5 seconds, and we have filled up to 465 mils, or milliliters.
465 mils in 5 seconds. Releasing the dye for trial 6. Oh yeah.
So trial 7 now, and we're going to open up the spigot another quarter turn. Trial 6, measuring the height of the water in the first piezometer, which is 3.5 inches. And the second one is 3.1 inches.
5 seconds.
Yep.
So this is trial 7, and we're going to measure the flow rate over 5 seconds, and start.
Stop.
So in 5 seconds, we have 510 milliliters.
Releasing the dye for trial 7.
Trial 8, and now we're going to turn the spigot. How much of a turn? A quarter of a turn. Open. So this is trial 8, and we're going to measure the height in the first piezometer, which is 3.6 inches. Second piezometer is 2.75 inches. And now we're going to measure the flow. And go.
Stop.
So that was 5 seconds. And we have filled, we're going to call that 600 milliliters.
600 milliliters in 5 seconds. Releasing the dye for trial 8. Oh yeah, you can barely see that. That must
in the first piezometer, which is 3.45 inches. And the second height. Whoa, okay. 2.6 inches.
Cool.
Yeah. Trial 9, now to measure the flow rate. And go.
Stop.
So in 5 seconds, we have filled up to 680 milliliters.
Alright, my friends, this is trial 9. We're releasing the dye. And you can't even see it at all. It's turbulent.
Trial 10, turning the spigot open a quarter of a turn. So this is trial 10, and we'll measure the height once again in
inches.
in inches. We have 3.25 inches for the first piezometer. The second piezometer is 2.75 inches. Trial 10, measuring the flow. And let's go.
Stop.
So in 5 seconds, we have 730 milliliters.
Alright, releasing the dye for trial 10. Oh wow, that mixing though. It's probably laminar. Just kidding, it's turbulent. Alright guys, we've made it to trial 11. It's our last trial, and I don't think any of you are still watching. But if you are, you get extra points. Just kidding, get a life. Just kidding, we're all nerds here.
Trial 11, we're going to open the spigot a full turn. Just kidding, quarter turn.
Quarter turn!
So this is trial 11, and we are going to measure the height of the water in the first piezometer, which is 3.25 inches. Height on the second piezometer is 2.45 inches. 11, flow rate, and go.
Stop.
So, in 5 seconds, we have 755 milliliters.
Guys.
5 seconds. Everyone, here's the last release of the dye. Here we go. Whoa, look at all that dye, but it's very well mixed. So we're gonna call it turbulent.
Okay, so for part 2 of the lab, we're looking at the energy and hydraulic grade lines. So this is the airflow stand. We have a vacuum suction system here. So air is pulled in through the straws, and this is laminar flow because we have all of the straws lined up. And then it goes through the piping here into our vacuum system. So we're going to be using a what is it called? A pitot rake. I can cut that out. A pitot rake or a pitot vane. And we're also going to be using the Venturi meter. And we're going to observe 2 different things with these. So for the pitot vane, we're going to be looking at the velocity and the no-slip condition for the pitot vane. We're going to be seeing how that changes in different points along a horizontal plane inside the tubing. And then for the Venturi meter, we're looking at the changes in pressure. So as we know, the Venturi, it decreases in diameter and then increases again. So we're going to be looking at the changes in pressure, and we can read those off of this board here, piezometer board, manometer board. And so we have different connections here. We have the Venturi connected on these connections, and then we have the pitot vane connected on these connections. And then we have the piezometer here on the end, and then we also have the atmospheric pressure we can read here. So we're going to be looking at the level of the fluid here, and that will be our 0 reading. And then we're going to turn on the vacuum pump, and then we're going to read the basically the deflection. And from that, we'll be able to plug in values into our equations for the Bernoulli equation and trying to figure out the hydraulic rate line. Okay, so just some more detail on the pitot vein. So these are all lined up horizontally on horizontal plane. So this is measuring the velocity of the air as it moves through the piping here. And this is the line for the piezometer. And this is measuring a difference in pressure. So, or just pressure in general. So you'll be able to see, you'll find the pressure and the different velocities here on the pitot vein, and then you can plug that into the Bernoulli equation and do your calculation. So just some more detail on the Venturi meter here. So we know we have a wider diameter, which is going to give us a higher pressure, but then we go to a smaller diameter, so lower pressure but higher velocity as compared to the entrance here. And then that increases in diameter, so then we have higher pressure but a lower velocity. And we'll be able to see these changes in pressure through the tubing connected to the manometer board. Now we're going to measure the slope of the manometer board so we can correct those values for our calculations. So we want to line up the middle here with the middle of the screw. And then we want to read right into the middle here for the best reading, and it's about 30 degrees. So now we just want to get the 0 reading before we turn the machine on. So we're looking at just the average reading for where all of these are, which is about 0.9. And then you'll see that the fluid will move and those readings will change as we turn on the vacuum. When you're ready. Okay, so now we're going to start up the air pump. So now we're going to do the same procedure with a Venturi meter. Okay, so you can see that now we just have the red fluid here in the tubing connected to the Venturi. So for the atmospheric is 0. For the piezometer 7, it is 0.19. Tube 6, 0.24. Tube 5, 0.32. Tube 4, 0.53. Tube 3, 0.63. Tube number 2, 0.29. Tube number 1, 0.09.
Too much time.
Is it?
Okay, releasing the die for trial 2. Oh, I totally missed it.
Flow tag. Okay. So, trial 6. Wait, should we redo that? I can't get too silly.